Okay, so picking back up in lesson 4.3.2, we did A. I think in your class, I just realized it's D. We did D, but I was doing it as the bell ring, wasn't I? So, just quick review. Cosine of 240 degrees. What do you know about 240? Where is 240 degrees? That's going to be in what quadrant? Third quadrant, right? 240 is down in third quadrant. So where is that closer to the x-axis? That's closer to 180. So how do we find the reference angle there? We're going to take 240 and subtract 180, yes? And 240 minus 180 is 60. You already told me this is down in quadrant 3, right? So what are we thinking here? When it says cosine of 240 degrees, since the reference angle is 60, that's 60 degrees below the x-axis, we're going to say, what is the cosine of 60 degrees in quadrant 3? So, according to our little handy-dandy chart, what is the cosine of 60? That was 1/2. Have that chart available, right? The answers are coming straight from the chart, nothing fancy. And then, is this positive or negative 1/2? Negative, right? Because over here, quadrant 3 is our T quadrant, our tangent quadrant. So that means tangent's positive in this quadrant, but sine and cosine are negative. This is cosine, so this is a negative 1/2. Does that sound familiar to what we talked about yesterday? Okay. B. So I obviously don't know my alphabet. I'm a math teacher, not an English teacher. That's my excuse there. Okay. Tangent of 5 pi over 3. You can go to the unit circle, or you can kind of try and think logically there. Where's tangent of 5 pi over 3? If we go and look at the unit circle, where's tangent of 5 pi over 3? Fourth quadrant, yes? Whether you're looking at the one in your notes, whether you're looking at the separate paper one I handed out, whether you're looking at the one over by Ethan. You've got, got a unit circle to look at. So 5 pi over 3 is in quadrant 4. So I need this to be a reference angle. I need this to match up with our pi over 6, pi over 4, pi over 3. It's closest to what we would normally say is 360, yes? But what is 360 in radians? 2 pi radians. So we need to take 2 pi radians and subtract it. Now, I say take 2 pi radians. What is 2 pi in terms of thirds? 6 pi over 3. Are you following here? If I'm going to say that I want to do, let's see, I'm trying to figure out how I want to write this. 2 pi minus 5 pi over 3, then that means really I need to do 6 pi over 3 minus 5 pi over 3. And 6 pi over 3 minus 5 pi over 3 is pi over 3. Are you following that? Tell me if you're not. Let me re-explain. Let me draw pictures, whatever the case is. But it's closest to 2 pi, so I subtracted from 2 pi. So this means when I do this problem, I'm asking myself, what is the tangent of pi over 3 in quadrant 4? So according to our chart, what is the tangent of pi over 3?
Square root of 3.
Square root of 3. Positive or negative square root of 3? Negative. We're in quadrant 4. Quadrant 4 is our cosine quadrant. So cosine's positive, but sine and tangent are negative. So negative square root of 3. Questions there? Okay. Well, since I seem to not be able to follow alphabetical order, we're just going to keep following my trend here. We're going to do E now. Cotangent of 19 pi over 6. What do you notice about 19 pi over 6? My response? It's big. It's bigger than what? It's bigger than 2 pi, isn't it? It's bigger than once around the circle, which makes it hard to figure out where is 19 pi over 6 going to land. So, do you remember what I had us do yesterday? We're going to take 19 pi over 6 and do what with it? So we can get it to a workable angle.
Subtract 2 pi.
Subtract 2 pi, you got it. So 19 pi over 6. I'm going to subtract 2 pi. What do we know about 2 pi this time? This time I'm working with a denominator of 6. And so 2 pi is going to be 12 pi over 6. 2 pi has a lot of different forms, doesn't it? And we go with whatever one we need. In this case, I'm working with 6, so I'm going to subtract 6. 19 pi over 6 minus 12 pi over 6 is 7 pi over 6. Is that a little more reasonable? That doesn't strike me as, oh my gosh, huge. I don't know where to put it. Is 7 pi over 6 on our unit circle? Now we can work with something. Where's 7 pi over 6 fall? It falls over here in quadrant 3. Where is it closest to the x-axis? It's closest to 1 pi, correct? Because right here it's in quadrant 3, so it's closest to 1 pi. So that means I want to know how far is 7 pi over 6 to pi. And 7 pi over 6 to pi, so what I'm going to do here, if you need to write it down, is I'm going to take 7 pi over 6, and I'm going to subtract 1 pi. What is 1 pi in a good form now? 1 pi is how many sixths? 6 pi over 6. And 7 pi over 6 minus 6 pi over 6 is pi over 6. The magical coincidence of, again, is that one of my reference angles on my chart? Yeah, that's one of my 3 big ones, isn't it? So now, what am I asking myself to do this problem? What is the cotangent of pi over 6 in quadrant 3? So, are you comfortable with thinking cotangent? Maybe yes, maybe not. What else can you think? If you don't like thinking cotangent of pi over 6, it is the reciprocal of pi over 6, if you'd rather think that way. Okay? I don't care which way you think. If we go to our chart, what is the tangent of pi over 6? Well, okay, I didn't say the right thing there, but yeah. Wait, no. The tangent of pi over 6, yeah, is square root of 3 over 3. Or in other words, it's 1 over square root of 3, right? So then when you flip it for cotangent, it's square root of 3 over 1 or square root of 3. Okay, or you have that chart that has everything written on it, yes. So that's an option as well. It's up to you whether you know, how you want to do with that. Are we okay that ends up at square root of 3? I kind of botched that explanation there. You're going to the chart, right? I need to get the chart written on the sideboard. I keep running out of time to do that. But you have the chart in your notes, right? Positive or negative square root of 3? We're talking quadrant 3 here. What do we know about quadrant 3? It's my T quadrant, so tangent's positive, and thus cotangent is positive. So positive square root of 3. If you have questions, ask me, please. I can't tell if we're just processing sometimes or if we're okay. Let me know if there's questions I should answer. And I think some of you are just working ahead of me too, so no complaints there. Just stating. Okay, backing over to C. Secant of negative 3 pi over 4. Thoughts about negative 3 pi over 4? Are you someone that you can you're okay with the negative and you know where negative 3 pi over 4 ends up? If so, work with it. Because what's negative 3 pi over 4 going to do? It's going to take me down and end up where? Not quadrant 4. Quadrant 3. Because when I do 1 pi over 4, 2 pi over 4, and here's 3 pi over 4. Okay? Now, if you are against the negatives, you don't like going backwards around the unit circle, then what do I do to find this a new name? Take negative 3 pi over 4 and what do we do to find an angle a new name? Add or subtract 2 pi. What is 2 pi? Yeah. 8 pi over 4. So negative 3 pi over 4 plus 8 pi over 4 is 5 pi over 4. That's a coterminal name. Now, if we look at 5 pi over 4, I'm now going up and around, and notice I'm still over here in quadrant 3, aren't I? So we need to know that we are in quadrant 3. Okay. Where is this closest to the x-axis? It's closest to the x-axis at pi. And so I'm going to take 5 pi over 4. Since 5 pi over 4 is bigger than pi, I'm going to subtract pi. What is 1 pi in terms of fourths? 4 pi over 4. So 5 pi over 4 minus 4 pi over 4 is pi over 4. So the question we're asking ourselves is, well, you can ask it a couple different ways. What is the secant of pi over 4 in quadrant 3? Or you can say, what is the reciprocal of cosine of pi over 4 in quadrant 3. I don't care which way you ask this. Okay. Sine and cosine of pi over 4 are the same, yes? You have those memorized? Sine and cosine of pi over 4 are both square root of 2 over 2. Although if I back up to the unrationalized, it comes from 1 over the square root of 2 if you're looking at your chart. So I need the reciprocal of that. What's the reciprocal of 1 over square root of 2? Square root of 2. Or it's on your chart as the secant of pi over 4 is square root of 2. Positive or negative square root of 2? Okay, we're in quadrant 3, which is the tangent quadrant, so cosine is negative. So negative square root of 2. Okay, F. Cosecant of 495 degrees. What do you think when you see 495? I voiced my opinion on the one above it earlier. 495 is?
Too big.
Big, right? Too big. I don't know where 495 is off the top of my head. I have to really think on that. So in order to figure out where 495 is, what am I going to do? What? That is not what I made. I'm going to take 495 and subtract once around the circle. 495 minus 360 is 135. Okay. That doesn't intimidate me as much, right? I feel like, okay, 135, I can handle that. I know 135 is going to be where? Quadrant 2. It's before I get to 180. That's what goes through my brain. I don't know how you think it through, but I'm thinking, okay, it's before I get to 180. It's past 90 before I get to 180. No, I don't have a spot to write my quadrant 2 there. So it's going to be in quadrant 2. How do I find the reference angle? How far is 135 from 180? How do I figure out how far apart 180 and 135 are? I'm going to subtract, except this time I'm doing 180 minus 135, which is 45 degrees. So I am saying, what is the, why do I have so many problems with cosecant? The cosecant of 45 degrees in quadrant 2. Or, if you don't like that, you're going to say, what's the reciprocal of cosecant? What's the reciprocal of sine of 45 degrees? Didn't we already do the reciprocal of this earlier? Yeah, previous problem, didn't we? Okay. Sine of 45 is square root of 2 over 2. When you reciprocal that, it ends up just being the square root of 2. Positive or negative square root of 2? Positive. Because we're in quadrant 2 this time. That's my sine quadrant. So if sine's positive, then so is cosecant. Any luck? Is it getting easier? I know the more intimidating ones are the big ones and the radians. But this is why I'm trying to give you tricks of, okay, how can I make these workable? Subtract 360 or 2 pi if they're big. And then, try and use what you know. Figure out, where's it closest to the x-axis? Where is it closer to either 180 or 360, or pi or 2 pi? Okay. That's one of the big things you have to learn how to do, okay? That is a big, and I kind of want to say a beginner thing. I mean, that carries through to a lot of trig we do, is being able to use reference angles. Okay, so big step to, or big skill to carry on there. Now, the bottom half, I have the examples on the next screen, but we'll talk here for a moment. Angles whose terminal side lie along one of the coordinate axes are called quadrantal angles. We actually talked about quadrantal angles yesterday in the homework questions, and I showed you one way to talk about them. Remember how I drew a physical triangle that had a side length of 0? And I said, okay, this is just kind of trying to give you a visual, but we're going to talk about other ways to do those. This is the place. Okay? So these do not produce reference angles. So we have a special way of finding them based on the unit circle. In other words, they're not going to be 30, 45, or 60 degrees from the x-axis because they're going to be on one of the axes, whether it be the x or the y-axis. So I think, let me see, what do I have on the next page? Okay, so as I already mentioned, I did have this on here, I wasn't sure. Quadrantal angles is what we're talking about. In an ordered pair, and I've kind of already tried to reference this a little bit on your unit circle, but in an ordered pair on the unit circle, when your radius is 1, that's the idea of a unit circle, is we have a radius of 1, the x value is the cosine value. X value is the cosine value. The y value is the sine value. And all your trig functions can be found based on these. So on the unit circles I provided you, did you notice I wrote cosine on an axis and sine on an axis? Sure.
I had to run my keys on.
Okay. So usually you just break right in. Okay. So on the unit circles I provided you, x-axis is cosine axis. Y-axis is the sine axis. Okay? That's key to know. I just mentioned that the x value is the cosine value, y value is the sine value. Everything can be found based on these. So you've kind of got a little bubble over here, kind of reminding you. You will see me a lot as we go through this chapter. Write down in an ordered pair, cosine, sine. You guys all still have these unit circles? Have these near somewhere? Have you guys looked at the ordered pairs out here? Craig, did you get one of these?
No, I never got one.
You do have it in your notes, but you're going to want one of these. Okay. Come test time, you're going to want specifically one of those. And I've got lots of extra copies if you've lost it already or misplaced it or whatever. But I'm trying to think. The unit circle, yeah. The unit circle in the notes does not have what I'm going to talk about here. But notice, what does it say right there by pi over 6? What's that? There's an ordered pair by pi over 6, yes? Do those values look familiar? They should. Because if the x value is cosine, what's the cosine of pi over 6 according to our chart?
Square root of 3 over 2.
Square root of 3 over 2. What's the x value in that ordered pair? Square root of 3 over 2, yes? What's the sine of pi over 6 according to our chart? 1/2. What's the y value in that ordered pair?
1/2.
1/2. So those right there, as you look around the unit circle, those are helpful to realize, helpful to understand that those are cosine sine values. Okay? We still need to be able to find these using our reference angles, which is what we're working on, but good to know. Now, based on this, and based on the idea that we're talking about the unit circle, radius 1, ordered pair, cosine x, sine y, on these quadrantal angles, well, let me go through the example first, but we'll come back and talk that sine is always going to be the y value, cosine the x value, And then tangent is y divided by x, because it's sine divided by cosine. So let me do an example here. Let's look at A. Sine of negative 270. Okay, visualize, guys. Where is negative 270? Negative says we're going to start where? We're going to start at 0 and we're going to go clockwise. So we're going around clockwise. So that means over here I'm at negative 180. Where's negative 270 take me? It's going to be the same as the 90-degree angle. Okay, so the idea here is we're talking about the sine of 90 degrees. I know it says negative 270, but we're going to talk about the sine of 90. That's the other name for it. If you go up here, what is that point on the unit circle? So if you go left or right, 0, and then you go up, what is that point on the unit circle?
0, comma 1.
Yeah. Right there is the ordered pair 0, 1. What did we just talk about with the ordered pair? The x value is the cosine value. The y value is the sine. What is the sine of 90 degrees? What's my y value in the ordered pair? 1. So what's the sine of 90 degrees? 1. And maybe I should point it out on here. I didn't think about this. I don't want you necessarily, trying to figure out how I say this, relying right here. But notice, if you look at the unit circle I provided you, you see 0, 1 on there? So that's reminding you you're going left to right 0, up 1. So ordered pair 0, 1. If my y value is sine, then the sine of 90 is 1. Questions on that? Let's try the next one. That'll give me a better idea if you guys are with me or not here. Tangent of 3 pi. What do you know about tangent of 3 pi?
It's more than 360.
Okay, it's more than 360. I don't look at 3 pi and think, oh my gosh, it's big, like I said earlier. But it is kind of big, right? It's bigger than 360. It's bigger than 2 pi. So what is 3 pi the same as? We're going to take and subtract 2 pi, right? Take off once around that unit circle. 3 pi minus 2 pi is pi. So what we're really asking ourselves here is what is the tangent of pi? Tangent of pi. So tangent of pi what's that ordered pair I have to consider there? Okay. That ordered pair right there is negative 1, 0. Because think about it. If we have that point on the unit circle, where does it go? It goes left 1, up or down 0. It's also on the unit circle here, right? Now, what do we say about tangent? Tangent is y over x. What's my y value here? Y value is 0. X value is -1. 0 divided by -1. 0 divided by anything is 0. I see a few of you with your calculators out. Did you try it in the calculator to see? Okay, this is one that would come up in the calculator. Again, you need to know how to do it without the calculator, but this is one that would come up in the calculator correctly, wouldn't it? Okay, C. Secant of 11 pi over 2. That's just a... Your guys' printed notes don't have a negative there, do they? Okay. It must. I think it's how I scanned it in. It looks negative, doesn't it? But I don't have negative there. Okay. You guys tell me now. Secant of 11 pi over 2. What are your thoughts about 11 pi over 2?
Big.
Big. How do I make it smaller?
Subtract 2 pi.
Okay. It is bigger than once around the unit circle, right? It's bigger than 2 pi. So we're going to subtract 2 pi. What's 2 pi look like in this case? Good. 4 pi over 2. 11 pi over 2 minus 4 pi over 2 is... 7 pi over 2. Have we had this happen before? What's the situation we're in? 7 pi over 2 is still big. Thank you, Jacob. Still big. So what can I do again? Subtract 2 pi as many times as you need to. We talked about that the first day we were working with coterminal angles. Subtract it again. What's 7 pi over 2 minus 4 pi over 2? 3 pi over 2. Is that something we know? Is that something that's on our unit circle? It is, isn't it? So, where is 3 pi over 2? Where is it, David?
270.
Same as 270, right? I say work in radians, but I get it. It is also easy to equivalent into degrees. So what is that ordered pair at 3 pi over 2?
0.
Good. Because you're going to go left to right 0, down 1. So, what are we trying to find? We're trying to find that secant of 3 pi over 2. What do we know about secant? It's the reciprocal of cosine. Okay. This is a different one to think, but so what is the cosine of 3 pi over 2? The cosine is 0. What's the reciprocal of 0?
0.
No?
Undefined.
Undefined. Remember that from yesterday? We talked about that yesterday because if I think of the cosine of 3 pi over 2, okay, so what's 0 as a fraction? 0 as a fraction is 0 over, we'll say 1. So what's the reciprocal of 0 over 1? 1 over 0. Does that help with the understanding there? That was something we talked about yesterday, is that a good concept to know going forward is the reciprocal of 0 is undefined and vice versa. And later on in this chapter, we look at the graph, so you'll get to see what that means as a graph. Okay, let's see. If I pick one more to get in, we can just go ahead. Let's jump down and do F. So I'm going to have time for about one more, and then I'll have to call it quits. So let's jump down and do F as a class. Negative pi, cotangent of negative pi over 2. Where is negative pi over 2? You have options here. What are your thoughts? Okay. Tori's going to go straight for it and say at 270. Because what do? If we go negative pi over 2, remember you're going down and around that circle, right? And if we go down and around that circle, that's one way to get there. Now, if you are still thinking, yeah, I'm not sold on those negatives, could you change that to a positive? If you want the coterminal angle, remember you can find that equivalence. Take negative pi over 2 and add 2 pi. And so add 4 pi over 2, and you're at 3 pi over 2. Or, in other words, as Tori said, 270.
Jake Chapman, please come to the high school office. Jake Chapman.
Okay, so we are trying to find the cotangent of 3 pi over 2, which is the reciprocal of tangent. Okay. What's the ordered pair down there? Left or right 0? Down 1 gives me the ordered pair 0, negative 1. For tangent, we do y over x. So what's that mean we do for cotangent? X over y, which is going to be what class?
0 over negative.
Yeah, 0 over negative 1. And 0 divided by anything is 0. Okay. What I think my plan is going to be. I'm going to stop here. Do you feel like you're doing okay on these quadrantal angles? Did you guys try the 2 I skipped? Some of you did, I know you did. If you try the 2 I skipped, you would have gotten answers of undefined and 0. Okay, so I would encourage you to try those, make sure they're making sense. My plan is I will record a couple of the examples on the back page tonight. I'm going to record those examples. I will leave a video for you guys for tomorrow. So plan tomorrow when you come into class. I'll try and keep it a relatively short video to watch over the back examples. And then you need to complete the homework, page 347, 21 through 48 for Monday. Sound good? Okay.